Alright, in this video we will see more examples on how do we apply this formula, okay? If there is a function in the denominator and its derivative function is in the numerator, then the integral of that ratio or that quotient dx is equals to natural log of the denominator function plus c. You can show this by using the substitution method, but you don't need to because we already saw a couple examples using that, okay, that method, and then now you can generalize as a formula, this as a formula. Okay, now let us look at this. So what is the denominator function? There is x cubed minus 3x squared. If you find out the derivative of this, what do you get? You get 3x squared minus 6x, right? If you find the derivative of, if you set this as like u, and if you find out the u prime, what will be the u prime? That will be 3x squared minus 6x, right? But do we have that u prime on the top, on the numerator? No, we do not. So what do I need to get that u prime on the numerator? Is you need to multiply by 3, right? Because if you multiply each of the term by 3, then you'll get 3x squared minus 6x. So we need to multiply by 3. But you cannot just multiply by 3, you need to balance that, right? So what I'm going to do is I'm going to write 1/3 and then writing 3x squared minus 6x, right? And then divide by, because you are just multiplying 3, and then basically what you're doing, I can do that one more step here. So what I'm going to do here is I'm multiplying this by 3 and then dividing this by 3. If you cancel that, it will be same as the previous one, right? And over, and then x cubed minus 3x squared, right? dx. Now what do you get? You get 1/3 and then integral 3x squared minus 6x divided by x cubed minus 3x squared dx. Now you have perfectly this format, right? There is a u in the denominator, like x cubed minus 3x squared is like u, and the derivative of that is 3x squared minus 6x. So there is a function in the denominator whose derivative is in the numerator. So the final answer will be 1/3 and the natural log of the denominator function x cubed minus 3x squared and then plus c. That is the final answer. Okay, guys? All right, let us do one more example here. That will be, look at this. So what is in the denominator? So there is x cubed plus 6x squared plus 5, right? So if you find the derivative of the denominator, what do you get? You get 3x squared plus 12x. So the derivative of the denominator, that thing will be 3x squared plus 12x, right? But do we have 3x squared plus 12x on the numerator? No. So what is missing? So you need to multiply and divide by the 3 again, because it is missing 3. If you multiply by 3, you will get exactly the derivative here, right? So basically you will get 1/3. I am dividing by 3, and then similar to the previous one, I am multiplying by 3. I will get 3x squared plus 12x, right? And then divide by x cubed plus 6x squared plus 5. By the way, you may be curious, what is the derivative of 5? It will be 0, right? The derivative of a constant, of a number, is 0. That's why when you find the derivative of the denominator, you just find the derivative of x cubed plus 6x squared, and then this has derivative 0, right? So dx. So here there is a function in the denominator whose derivative is in the numerator. So the integral of that quotient, that ratio will be, so 1/3 is there, natural log of the denominator function, that will be x cubed plus 6x squared plus 5 and then plus c. That's how you do it. All right. Now that was question number 12. This was question number actually 16, okay, from the book. And now I want to do another problem here, that is question number 22. Okay, so think of this. You see that in both of these, you see that what is the degree of the denominator here? That is 3, because the highest exponent is 3, right? So what is the degree of the numerator? 2. So the numerator degree is 1 less than the denominator degree. Then you can think of it may be the derivative of the denominator, may be the numerator. You can think of that way, right? Here too, the derivative, the degree of the denominator is 3, degree of the denominator is 2. Sorry, numerator is 2, right? So again, you can think that the derivative, when you find out the derivative, the exponent will go down by 1, right? So that's why it makes sense to think of that the derivative of the denominator may be numerator, right? But on 22, the numerator has a bigger degree than the denominator because it has 3 and the denominator has 2. So in this case, we may have to do something else, some more thing before we apply these techniques that we used, right? So if the degree of the numerator is bigger, then try to get the factors of the numerator and the factors of the denominator and cancel that. But the safest way is get just use the long division and then find the quotient and remainder of this one. Okay, so let us try that. So what I'm going to do here is I want to just find out that the divide the top by the bottom and then find out the quotient and remainder. Okay, so what I'm going to do is x squared minus 5 is the divisor, and then x cubed minus 4x squared minus 4x plus 20. Okay, it is the dividend, right? So when you divide by using the long division, you may know that already. Okay, so what you need to do, divide the first term by the first term, that is x cubed over x squared. How do you get? You get x, right? So write down that x here, okay, and then multiply that x with both of the divisor. X squared times x is x cubed, right? And x times negative 5 is negative 5x. You see that? Now you may be curious, why do you write? Because there is negative 4x squared. You can write, if you want to, you can write that because there is no x squared term when you multiply. So what I'm going to do is I'm going to write down that negative 5x just below that negative 5x, like that. Okay, now what are you going to do is you are going to subtract means change the sign. So x cubed minus x cubed is 0, and then negative 4x, this will be minus, so it will be, when you subtract negative 5x, it will be plus, right? So it will be negative 4x squared because it is on the top row, and then plus x, 4x squared plus x plus 20. That's what you get after you subtract. Now again, you divide the first highest degree term by that one, you'll get negative 4x squared over x squared. If you divide, you'll get negative 4, right? Now write down negative 4 on the top, negative 4 on the top, okay? And then negative 4 times x squared is negative 4x squared, right? Negative 4 times negative 5 is how much? That will be positive 20, right? I just skip spaced here, right? Because there is no x, that's why. So what I'm going to do is subtract again. When you subtract, you just change the sign, that will cancel out, right? You are changing sign, that will cancel out. So what is the remainder? X. Now we are not dividing x by x squared, okay? So what you can write, that thing is basically you can write x cubed minus 4x squared minus 4x plus 20 divided by x squared minus 5, right? X squared minus 5 can be written as how? You can write the quotient minus x minus 4, right? And then plus x, the remainder divided by the divisor, x squared minus 5. That's how you can write this ratio, this quotient, right? Now this is equals to that thing. Basically what is happening there is this thing, this ratio is equal to that thing. So we are replacing that, okay? So how can you write that then? So therefore the integral that x cubed minus 4x squared minus 4x plus 20 divided by x squared minus 5. You see that? That can be written as what? That can be written, also don't miss dx. That can be written as x minus 4 plus x over x squared minus 5, and then dx is there. So you know that in the integral you can distribute this integral to each of the term. Okay, so let us see that. What is the integral of x? That will be x squared over 2, right? You know the formula, right? What is the formula for the x to the n? You see that? The formula for x to the n, integral of x to the n. Oh, this doesn't have the integral formula, but integral of x to the n is basically, so let me write down that integral of x to the n is equals to x to the n plus 1 over n plus 1 plus c. I will write 1c at the end because every time for each of the term you'll get a constant, so you write a overall constant, just single constant to represent all of those, the sum of all those. Okay, so the integral of x is x squared over 2 minus integral of 4 is 4x, right? 4x, because the derivative of 4x is 4, that's why. Okay, the derivative of x squared over 2 is x, that's why we're doing that. And then plus, what I'm going to do is, because I don't know what is the integral of this right now, so what I'm going to do is I'm going to do x over x squared minus 5. You see that? And then dx. Okay, now what I'm going to do is so I will write plus c at the end. Okay, no worries for now. All right, so let me copy that first two terms because they are already free from the integral, x squared over 2 minus 4x, but plus, now think of this. Can you use this formula? Can you use that formula here or no? What is the derivative of x squared minus 5? It is 2x, but there is just x, right? So what I need to do there is I need to do 1/2 times 2, and then that 2 and 2 will cancel out. Basically, you'll get x over x squared minus 5, but the derivative of the x squared minus 5, you get 2x, all right? So what I'm going to write is 1/2 and then integral 2x over x squared minus 5 dx, and then I'm using that formula, right? So what is the final answer then? X squared over 2 minus 4x plus 1/2 natural log of the denominator function with absolute value 5 plus c. That's what you get. So that is the final answer. Okay guys, so let me do one more problem on this video. I'm going to do question number 23 from the book. 23. The question is integral of natural log of x square over x and then dx. Okay, so how do I do this problem? So to do this problem, so you see that you cannot use this directly, right? You cannot use this formula directly because there is no function in the denominator whose derivative is in the numerator. There is no, it doesn't apply right now, right? So what I'm going to do is I'm going to use this substitution method. Set natural log of x equals to u. You know the substitution method from Calc 1, right? From chapter 4. So what is the derivative of natural log of x? 1 over x dx will be du. Oh, that's nice, because 1 over x, because there is like 1 over x dx will be du. So this will be u square, right? Therefore, what you can write is you can write u square, and then times du, right? Because 1 over x dx will be du. This will be u square, right? So what is the integral of u square? That will be u to the 3 over 3 plus c, right? That is the integral of u square, because the formula of x to the n will be x to the n plus 1 over n plus 1 plus c, right? That's what we have it here. Okay, so so now, but our question is in terms of x, so we need to plug in back in terms of x. So that will be 1/3 and then natural log of x to the cubed and then plus c. That is the final answer. Okay guys, so we will take more examples, okay, to see a variety of problems there. All right.